Let's read the problem first. A disk is free to rotate about an axis, that's the axis of the disk, passing through its center and perpendicular to its plane. Moment of inertia of the disk about its rotation axis I. About this axis, moment of inertia I. Light ribbon is lightly wrapped over it in multiple layers. End of the ribbon is pulled out at constant speed. Let the radius of the ribbon be r, thickness be d. Find the force required to pull the ribbon as a function of radius r. So our plan is that the force is applied here, or is applied here tangentially. So force multiplied by r is torque is equal to I times alpha. Sorry, and alpha is rate of change of the angular speed d omega by dt. So let's name the equations, equation 1 and equation 2. And again, one more clue, you have r omega is equal to u, that's constant. So that's one more clue. Another clue is that, see, the rate of mass which is lost, the rate of the mass, or the rate of loss of the ribbon. Okay, so if you consider the ribbon here, so let the width of the ribbon be w, so that's the ribbon being pulled out. Okay, this little thickness is d, and the ribbon is pulled out with a speed u outward. So that's this thing, this is the amount pulled out in time dt. So that distance moved in time dt is u times dt. So how much of this ribbon is pulled in this time? So the volume of the ribbon which is being pulled out in time dt, so in time dt, volume of the ribbon pulled out is equal to width, volume is w times u times dt times thickness is also d. Okay, so dt, that d and it's d, don't confuse it. So so this is actually this dv, right? dv, v for volume, so that rate of loss of volume, this dv dt, or rather that's the volume pulled out, dv dt is equal to w times u times d, where v is the uh, volume of the ribbon. Now this is equal to the this wud is equal to minus of ddt of minus of the rate of change of volume. So that is pi r square minus pi a square times w. See what I have chosen here. Say the inner radius is a and the outer radius is r. So I am just writing this now, volume. So how much volume of matter you have, how much volume of the ribbon, and that's surely pi r square minus pi a square, this thing multiplied by w, the width. I mean the width is here, as you know of it, the width is here. Okay, that's a 3D diagram. I've shown the width here. Okay, okay, so what does that come out? So w times u times t is equal to minus of pi 2r dr dt. So that is another equation 5. So that's this is what we need, this equation. And from this equation 3, if you differentiate r d omega dt plus so omega times dr dt, omega times dr dt is equal to 0. Therefore d omega dt is equal to minus omega by r times dr dt. That's one more equation. Let it be equation 6. So there are this. So we will need this equation 6. We need this equation 5, and also equation 1 and 2. 1 and 2 combined. So let's see. Let's work out here. So f times r equal to I alpha means d omega dt, and from equation 6 d omega dt is minus omega by r times dr dt, and dr dt from equation 5 again. So f into r equal to I times, this minus sign will cancel out. Now this dr dt is equal to WUD divided by 2 pi r. Okay, now what about this omega? This omega, is there any omega? Omega and W both are there, right? So that's omega. This is omega, so quickly replace it by U divided by R. Okay. So therefore now 1 R F, this R will come here, becomes R square. So F is equal to I this R becomes I U square W D by 2 pi R. Oh, here this W will cancel out. This W will cancel out. W is not there. W has cancelled out in equation 5. You have a W here and a W here with here. So I times U square D divided by 2 pi r to the power 4. Yes. So that is the answer. Force equal to I U square D by 2 pi r to the power 4.